So then I get 5.5J plus 5.5W, so those want to die, equals. I was
2,792.5.
going to try to do it. What is it?
2,722.
Did you do that in your head?
22.5.
There's nothing going on up here, bud. I got a handful of empty and heart.
And then what do you do?
You
Yeah, let me cross through this, because I changed it to this, and now I can just do what with these? Add them together, because now I set it up so these will die. Is that the only way to do this? No.
That would be 11.
Go what you like, beat it, run from. You guys all right with that?
Okay, you're kind of take these.
So
what's
five. So you get 11J. These cancel. There you get something or other. I don't know. 5,197.5.
797. Yes.
And then you divide by 11.
472.5.
Oh man. What does that mean?
That's J.
Of jet.
Good. What's that mean?
Of jet.
It's the speed of the jet.
Speed of the jet.
Still.
So what's the speed of the wind?
575.
You kind of plug it back into one of them.
Minus
Shit.
W.
Whatever the flip that becomes. You guys okay with that? Yes. So you get the wind, you just plug that number back in for J
Do
into
it.
one of these.
Do it.
You solve.
Do it, man.
I don't want to. Yes.
It kind of has to do. I was just asking, like, the question was asking, like, was 1,000 people took a survey and 650 answered yes on it and 350 answered no on it. And then they asked you to find the percentage and the average. You could, is that right?
You can find the percentage. I don't know what you know with the average.
Like the average.
Average what?
Oh yeah, because
It would just be a percentage.
Yeah.
Yes.
Can you do 403?
Oh, okay. So this one's a little bit like what we just did. So Kathy left home to walk to the mall, walking at a rate of 4 miles an hour. Who's this go? That's Kathy. That's Kathy for you. We'll just put that. Okay. Kathy.
I should have named this.
Her sister Abby left home 15 minutes later. Oh man. Almost. 15 minutes later. Maybe a little bit better. Going 10 mile an hour or so. Rode her bike going 10 mile an hour. So she's trying to catch Kathy. Okay. How long until she catches her? So how long until Abby catches up? Yes.
So, the way you set this up is you see how long it takes for them both to go the same amount of distance? Like for Kathy to go 8 miles and for Abby to go also 8 miles?
Yeah.
See how long that takes?
What are my unknowns? Read the question. There's two. There's only one that the question cares about, but that's stupid. Is the time.
Until Abby catches up.
Yeah.
So the time, yeah. So Abby is going for a certain amount of time. So A is Abby's time. And
Okay.
K is Kathy's time. Now this one is a type of problem that's just barely worth doing two variables, but I'm not going to say more than that. We'll see what happens. Is everybody with me? You see how I got there? The question wants to know how long until Abby catches up, which means the variable should relate to the times of both of them. I like it. So if I start to put this together, Abby, Kathy, Abby's going 10 mile an hour and Kathy's going 4 mile an hour. Abby goes for A and Kathy goes for K. And so how far did Abby go?
10.
10A. Distance is rate times time. 10 times 8. Bam.
4K.
4K. All right, let me stop there for a second. I mean, I don't have to worry about the 15 minutes later because it's going to be one of my two equations that relate the A and the B. A and the B, A and the K. What's got to be true about these? They equal each other. So one equation is the distance Abby goes is the same as the distance Kathy goes, because Abby's got to frickin' catch Kathy, and that's when we stop, right? Catches Kathy, does whatever she needs to do. You bitch, you took my shirt. Whatever, I don't know. The second equation is the one I just talked about. Have we used this information yet? Abby started 15 minutes later. So Abby's time,
15 plus.
I'm going to make,
Kathy's time.
now be careful, 15 minutes later. So who's been out there longer? Kathy.
So K minus 15.
Now, this is not quite right either. I can't put a 15 there because that's in hours.
25.
15 minutes is how much of an hour?
1/4.
You know how much. If you look at a clock that's not covered.
15.
Where? Right there, it's perfect. Oh, shit. How much of the clock is that covered? 1/4 of it. So 15 minutes is a quarter. We know it's a quarter of an hour, right? Past 12. It's a quarter of an hour past 12. Easier than this at 12. So I really, we've talked about this before in this class. I can't put something that's minutes here when other parts of the problem have hours in them. So I got to make this 1/4. And what method does this seem to be? So this is equation number 2. What method would you use?
Substitution.
Shit, yeah. Because I know A is this. Bam. And that's on the key. I give you the key. I always forget that this our short day.
Why you didn't put A here in the table?
A, what do you mean?
A K minus 4, 1/4. Why you didn't put it in the table?
I could put that there, sure. And that sort of was my point about this is barely worth having two variables. So that's the point I was trying to make earlier, but I didn't want to make a big deal out of it. So, let me give you this. I think a few of you guys, well, at least Ollie, you need this. Anybody else not get their quiz back? Oh. Here is the answer.
You're extremely generous with these tests or quizzes. I appreciate that.
Well, people that got like 30s on them don't probably agree with me, but it's a whole other person here, right? So, well, hey, we got this case, why not you?
Yeah, let's divide this up into like discrete states. Districts. Yeah, like this is, this is Hollyburg. That's Spencerville. I don't know. Hollyburg. Hollyburg? Yeah. You can't.
It's not Hollywood, right?
Girls only.
I'm a girl.
That's not recording. Jeff, have you been getting my emails?
I don't know.
I just sent you an email before class.
So no. I'll get it when I get back to my
Okay, well, I
office.
sent it in the
Okay.
class, I'll be honest.
So that's about it right there, guys.
Bye.
See you, Tara. That's it. All right.
Jeff, yeah, so Dr. Jeff, so I sent you a very important email today.